Let me briefly explain what is the difference between the standard PVT process of silicon carbide and the closed-base PVT process of silicon carbide. From time to time, I'm mentioning this in my posts and my videos and in other events. And the usefulness of the closed-base PVT is that it's using the same principle of growth like the conventional PVT method. The closed-base PVT is used for making thin films on wafers. The traditional PVT method is making boules from which you cut and make wafers. But the physics and principles are the same. Let me show you some images. Here you can see the PVT hardware, the tool for the growth, the machine, on the left side. So this is very, very now simplified. And in the center, you see an illustration of the box where the growth happens. And when you place this box inside the tool, then you are creating growth of silicon carbide using the hardware tool and the hot zone. So the hot zone can be replaced by another hot zone. And in such way, you can distinguish if you want to make PVT growth for bulk growth, to make wafers, or you replace it and you can make epitaxial growth by the closed-base PVT method. And the principle is that you have a source of silicon carbide, powder as a ceramic or as a ceramic, and then when you heat it up, you have the vapor species which are formed. The silicon, 2 silicon, 1 carbon, 2 carbon, 1 silicon, and other ones. And then those are transported from the source to the growing substrate. And this is what is typically done in the traditional PVT. And this is a very simplified illustration now. And in comparison, on the left side, you see the traditional PVT, and on the right side, you see a modified hot zone for the closed-base PVT. And there you have a substrate, you have a source, and this is a ceramic source instead of powder. You decrease the distance, you decrease the growth temperature, you decrease the ambient pressure, and in such way, you can continue to use the PVT principle for growth, but you're learning about the process in a similar way. And the cost compared with the bulk growth is very much smaller because you don't need high quality seed, you have no seed attachment, and the graphite is not deteriorated by the growth. You can use the graphite many, many times in the closed-base PVT. So in such way, one can use the closed-base PVT for understanding the principle of the PVT process, and then learn about those things before you actually start with the PVT for the bulk growth. And that is an advantage for learning, but it's also an advantage for the research, because with the closed-base PVT, in modified ways, you can explore graphene on silicon carbide, fluorescent silicon carbide for white LED, you can grow cubic silicon carbide, and there are many other approaches. And for example, in our recent project, rePowerSiC, we're exploring doped silicon carbide for high power laser transmission. So energy transfer using silicon carbide. And the silicon carbide is collecting the energy from the laser, and then you can feed drones and things from long distances. So in such way, the closed-base PVT has many interesting possibilities, and at the same time, it's a learning process for the traditional PVT for the silicon carbide manufacturing.